Hello, everyone. Thanks for coming. We're here today to talk about disruptive virtual cinematography on a budget.
Because we came here to sort of try to dispel this myth that as a 2D filmmaker, you don't need to worry about immersive computing or care about it or even touch it. But the reality is that if you as a filmmaker are not using immersive computing in your filmmaking pipeline, you'll actually probably be left behind.
I'm Tarrnie Williams. I'm the CEO and co-founder of Blueprint Reality.
I'm Ben Sheftel, the CTO and co-founder. I've been working in Unity for about 8 years now, in VR for more than 2. I have a background in art design and programming, so I've got a pretty wide knowledge of the pipeline and workflows that go into combining these disciplines.
And I've been in tech for over 25 years, most of that in games, about 16 years with Electronic Arts, where I helped create Need for Speed, NBA Live, Medal of Honor. I was the general manager of Relic Entertainment, did Company of Heroes, Dawn of War. And really, most of my career I've been creating worlds. And when Ben and I founded Blueprint Reality and got into virtual reality, we really had at our fingertips a medium to create worlds like we've never been able to create before. And as we were working on our first game, a game called Awaken, we really wanted to be able to show people what was going on. And we found that it was incredibly difficult to show people who weren't in virtual reality what was going on in VR. And so, we looked around, we tried to find a solution, saw some early pioneering work in mixed reality, and we said, hey, that's really interesting. Let's dive into that and let's actually find a solution for that. And so our companies ended up focusing, on building a mixed reality broadcasting solution, and that's called Mixcast. And how that ties in is, we'll go through later on.
But as we were building Mixcast, we started to realize what an impact it could have on virtual cinematography, because we think it can actually be applied and radically change the way that filmmaking's done. And to go through that, we sort of have to go through a little bit of where VR is today. For a lot of you, this may be familiar, but we want to cover it anyway in case you aren't. And so you may recognize a few of these devices here. We've got the Oculus and one of the Windows mixed reality headsets. But really what we want to focus on is the HTC Vive and Steam VR tracking. At first, you had the headset, one of the primary components of VR systems. You put it on your face, it tracks your position in 3D space, and you can see a virtual world. But once we put on that headset, we realized we needed controllers. We wanted to see our hands, especially tracked in space. So out they came with the hand controllers. These are tracked, and the Vive was the first of the current systems to incorporate the hand tracking. But really what makes this possible is the Lighthouse system, these little base stations here, which allow you to have tracked devices in a space that they encompass. And you can see here they can be mounted on a tripod or attached to your wall in the next case. And the goal here is really just to blanket a space with these sensor lasers really under the hood in order to track devices within that area. In general, that's called room scale. And here's an example of what someone experiencing room scale VR looks like. Now, once we had that, people went on and wanted to track more things. Here's an example of someone trying to strap some extra controllers onto their legs and getting leg tracking. So HTC went on and said, look, let's just make an accessory that lets you track a generic object. This is the Vive tracker. And people are doing some really interesting things with tracking gun controllers or baseball bats to enhance their VR experiences. But really what we think is interesting is being able to track a physical camera in the VR system.
And so, let's dive a little bit more into mixed reality and why that's so important to, this talk, to virtual cinematography, and to virtual reality in general. Right now, 2D screens are the primary medium by which we communicate visually on the planet. Mobile devices, televisions, monitors. This is the way that everybody shares what's going on visually. And so, those of you who spent some time with virtual reality realize just how hard it is to communicate what's going on in VR. Putting a headset on, that's an incredible experience. You feel that presence, it's amazing, but nobody else knows what you're doing. You got a bucket on your head, you're being chased by a bee. Others do not get this sense of what's going on. Next up is, fine, you do the output from your headset. That's a bad cinematographer. It's jerky, you're all over the place. Really, you don't, again, get a sense that even, the person is in VR if you're watching it on a monitor or later on. You just don't understand what's going on. And so, mixed reality is this concept of let's take an image of a person and put them and composite them into that virtual scene so that we can now see, the person in the environment as they're experiencing it. And really mixed reality helps make virtual reality make sense. And so let's take a look at a little montage video that shows some examples of this.
So that's a great example. You can see now why that's such an intuitive format to be displaying VR experiences in. By incorporating that player, you now fully understand the context around how an experience is being played. So to go through the history a little bit more, because we do want to give credit, Kurt Gardner was one of the pioneers in this space, working on making mixed reality trailers for the Northways for Fantastic Contraption. And we can show a clip of what that looks like. Great game, by the way. Here's Colin Northway building a part for the game. And you can see how intuitive, again, it is. In this case, you can see the camera being tracked in space so that it can capture the action from a variety of angles. And the virtual world reacts and is shown in the same perspective. Kurt went on then to work with Alchemy Labs on a job simulator trailer, which is another VR title, which looks great in mixed reality and really helps sell that interaction and experience. But we should go behind the scenes to see how these types of videos were created, because it looks simple with the final product, but there's a lot going on under the hood.
So we're going to play a video that Kurt put together. It's about 4 minutes long, but we think it's very relevant to virtual cinematography as a whole. It probably does the best job of describing this. So, have a look, and then we'll carry on and sort of link all of these concepts together.
We are working on the Job Simulator and Fantastic Contraption trailers right now. They're the 2 of the 3 launch games that are coming out with the Vive. So when they approached me, I was really, really excited about it. I mean, I just really wanted to be on board with this kind of thing. My background is in visual effects, and I used to work on like a whole bunch of different Hollywood movies. After I got out of the visual effects industry, I sort of transitioned into video games and started doing more motion graphics. But these 2 trailers are the first ones that really merge those skills in like a really, really nice way. So generally speaking, I'm literally a one-man shop in my basement making game trailers, but for this, I knew we would need a green screen studio, we'd need a camera crew, we'd need people on set, we'd need actors, and so all of a sudden your needs are just growing exponentially. So I called Handcraft, and they were like, yes, let's do this. And so then we started to figure, okay, what cameras are going we shoot with? What are we going to use to stabilize the camera? We need to figure out which camera would actually fit in the stabilizers, and like, how do we attach the third Vive controller to that? And will that throw the camera off? And blah, 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 blah. It just keeps mounting on top. Right? And we did that first test in the basement, and I put it on Twitter and just exploded. People were like, whoa, my God, this is crazy. And so we knew we were onto something.
So today here we're recording VR trailers, which is kind of this new thing that people haven't had to think about before. And we're doing that with a green screen and doing some mixed reality stuff where we can kind of superimpose people into the actual game with a hope of being able to explain to people what VR is like. Actually showing people inside VR for the first time, that's really, really magical. And I think will kind of allow people to understand without trying it, just a little bit of what this stuff is going to be like. Job Simulator is a game coming out for all 3 VR platforms, the Vive, the Oculus with the Touch, and PlayStation VR. It's a game where robots have taken over all jobs. It's the year 2050, and so they created the simulator to simulate what jobs used to be like, so these future humans could experience what it was like to job.
Fantastic Contraption is a video game for VR where you use your hands and you walk around and you make a contraption. So you make a machine. You use these simple tools, you use just wheels and sticks, and you basically try to get from over here to over there.
Basically, every single time we would do a take on set, there was like this checklist of things that we would need to go through. So like the first thing we would do, make sure that the camera is rolling, and then make sure that I'm capturing gameplay on the computer. And we would have to get people to do a calibration of their hands with the controllers visible. And the reason we needed to do that is we needed some way to align the footage from the gameplay and the camera in post-production. So the screen would be split up into a foreground layer, a background layer, a composited layer, and then what the player was actually seeing through the head-mount display. So we're capturing all 4 of these views live at the exact same time as they were playing.
It was awesome. Kurt's crazy. As soon as we had our first Skype call with Kurt and he was telling us all his ideas, I was like, that's impossible. And after we saw the first few of his screen tests, it was pretty mind-blowing.
People aren't going to realize how much work this was. It's like, oh, they shot it on green screen, it's all computer. But no, what we actually did is we shot the gameplay live. So the gameplay was actually being captured at the exact same time. We didn't go in Cinema 4D or Maya and rebuild all this stuff. So literally it took 2 days of doing rough composites of every single one of these shots and just layering everything in, lining them all up exactly on the right frame, and spitting that all out into this big collection of files. Then once you have that, you can actually start looking at it and sifting through the footage. It's really the best way to showcase virtual reality. It's the best way to show that that person is in that environment and manipulating those objects. And a lot of people, you just say you have to try it in order to experience it. And I think that these mixed reality videos are the best way that we can get that feeling across, in a 2D format without having the headset on. Being involved in the first of these kind of things is really, really fun. It's fun to work through all the technical problems, and it's fun to figure out how to shoot in VR and what things you need to do to make that look good. So it was stressful, but it was really exciting at the same time.
So as you can see, there's a lot of post-production involved in that, a lot of prep. Obviously, if you're a filmmaker, you're going to be very familiar with the sets, with the lighting, with the cameras, all of these things. However, essentially what we're building there is, you're taking live actors and you're merging them with digital environments, which is essentially what is done in the, all the time in the movie industry and the film industry. And so, we thought about that and said, well, it would be, what are the challenges there? Well, it's, it's done in post, which means there's a whole process after you're shooting that takes a lot of time. It's expensive, it's time consuming, and it really doesn't give you the same kind of on-the-fly iteration or immediate feedback loop that you get if you're doing live shooting. You can just move a box around, you can adjust where your actor is, you can do a lot of things differently. And so we said, great, with Mixedcast, we want to solve all those problems and solve them into a live environment. And so that's what we did. With Mixedcast, it does these things dynamically and live and does a live composite. It makes it easy to show and share your experiences from the virtual world with mixed reality. So, we built easy chroma keying. Lets you, just drag and drop. I don't know if you've used other solutions, they're a lot harder. Again, we want to make this as easy as possible and high quality as possible. And what that lets you do is, then drop a person into a digital scene, into a 3D scene. This happens to be a game, doesn't have to be. You could load whatever scene you want into Unity and now essentially drop that person using a live compositing solution like Mixedcast or into that scene and be able to record them. So, lots of applications, esports, live performance, VR arcades, video production, communication, your business. But one of the businesses we realized actually that this was super critical for was filmmaking. And so now we're going to talk about, really for the rest of the talk, is about mixed reality, tracked immersive computing, and filmmaking, and that intersection between them in virtual cinematography and how those things go together.
So there have been a number of companies and people that have tried to merge these technologies together and come up with new workflows and new ways of making film. So one of the examples here is an AR kit application for iPhones called Blocker. And what it allows you to do is block out a scene using digital assets as well as the real world that you're holding your phone out in. You can reorganize those assets, capture perspectives that you'd like to save out for later, and really just get a sense of how your different subjects in your scene are going to interact, even if you only have the environment to begin with. Another great one is Mindshow. This is a room-scale VR application, which plays around with a lot of really interesting concepts about embodying virtual characters and set design and things like that. So I'd urge you to check it out, because it has a lot of depth to it.
And then, may have seen some things in the news. There's Disney has been diving into virtual cinematography. There's a really good behind the scenes on how they made Jungle Book. With that, here's a shot from on set. They used it really to do, blocking, and they were doing previs with it. So, filming a live actor. They've got other, stagehands moving across the scene, holding markers that they then put the water buffalo on top of. And you could tell that they, put a lot of work and a lot of time in this, but it was a pretty time-consuming and pretty manual process. My understanding, they've sort of mentioned only a few things about Lion King. I think they've taken this further and said they're using virtual reality, but that film's not out for, I think, 2 years, so we probably won't learn a lot about what they're doing until later. With Mixcast, we said, great, let's go figure out what we can do now on our vCinema product that is kind of in early beta. If you want to talk to us, we'll show you a link later on, and we'll show you kind of some of the things that work right now.
So one of the interesting features that we've got available to try right now is player lighting. This allows you to take virtual lights in your digital scene and actually apply their effect to the real actor. This greatly blurs that line between the real and the virtual, making it feel a lot more convincing of a production. One thing that cameramen are always looking for is the ability to sort of understand the outcome of their work. And so really what we want to do there, because we're using a real-time solution for mixed reality, is display that final composited output onto a screen for them to see. So you can see here we're streaming that output onto a cell phone that's attached to the camera. So they're immediately aware of not only the raw footage that they're capturing, but actually the composited footage as well. And once we sort of take that concept a bit further, we imagine that actually cameramen might want to wear that headset and have full awareness of the scene that they're capturing. In this case, we're actually going to have digital viewfinders. So here you can see again the raw footage and the fully composited footage available, and even a representation of where the camera is itself. Now, one other aspect of this that's really interesting is the ability to project this actor back into that virtual scene. So you can see here the cameraman could actually walk towards the actor and understand their relationship spatially to the objects. It certainly breaks down the closer to the side you get, but that camera alignment, the camera that's filming it, is still getting that pixel perfect accuracy. This just gives an added awareness of what the actor is doing and interacting with the scene. And one thing we really love to use is Unity's post-processing stack here, which can be used on the fly in real time to adjust that final output. We can add things like vignetting, bloom, color correction, all of the nice things that filmmakers might be familiar with. And another really cool feature that we've already got available is multicam. So this allows us to capture performance from multiple perspectives at the same time. You can see a couple mixed reality feeds there, as well as a static virtual camera in the top right, just trying to capture sort of an overview of what's going on. And in the bottom left, you're seeing the headset view.
And so next we're going to dive into some of the filmmaking process. I mean, caveat, neither of us are filmmakers. I co-produced one movie a long time ago, but there'll be a lot of things that filmmakers know how to take what we're proposing and bringing to people as tools further. And so I think what we want to lay out, though, is a bunch of the ideas, a bunch of the places where virtual cinematography is going to go, and what some of the capabilities that gives you in terms of shifting workflow. So we're going to walk through previs, recording real actors, recording motion and performance capture, post, and then go through 4 case studies in terms of how all of those pieces come together.
So for previs, we know this is a very important aspect of filmmaking. It saves you a lot of time in recording if you can capture things in advance to see how things are laid out. And in this case, what we want to do is capture screenshots and video clips, which can allow people to block out a scene, storyboard even, capturing storyboard panels, or even super rough cuts for reference. We want to be able to take that director or the director of photography and bring them into VR and allow them to not only view, but navigate through and manipulate that digital environment as they see fit. And as you just saw, we can include the actors' performance as projections into the scene, so they can even see what their actors are doing in relation to the digital objects. And you can also be framing shots just like you would in a real world, where you can take a camera, pick it up, and move it around to try to get a better shot and understand where things are going to be laid out. But you can even do this not just with that physical camera there that you're tracking, but also with virtual cameras that you can just manipulate digitally. And looking at the artist's perspective, they generally are locked out of the previs a lot until you kind of go through a long iteration loop and get feedback. What we want to do here is actually make the artist able to edit that digital scene and props and anything else digital in the scene and have really fast iteration, in fact on-the-fly iteration, to get immediate feedback from actors and directors. And so they could do this in Unity using the Editor VR tool if they want to put a headset on and be able to naturally and intuitively manipulate this environment on the fly. Now looking ahead, because that was all sort of stuff that we're at now, technology that's available, looking ahead, we want to be able to network our entire crew and actors. And so what we want to do is be able to distribute this work across various physical locations rather than being tied to one studio. We want to be able to incorporate things like voice commands for the director so that they can trigger recording, create new cameras, and talk to the other actors and crew in the scene. We think that with hand tracking coming out pretty soon, the Leap Motion and some other devices like that, we'll actually be able to have directors frame a shot using their fingers and even trigger capturing and recording of that shot just with their hands or voice commands. And we also see depth cameras becoming more important. What they allow for is not just that 2D representation of the player, but actually being able to create more of a 3D model of them so that you get more accurate results, even with virtual cameras that are capturing maybe from a less aligned perspective. And these virtual cameras can then actually become a lot more powerful. We can start authoring motion for them and setting up behaviors using trackers where a cameraman can just be holding onto a tracker and manipulating a virtual camera using it rather than actually having a physical DSLR that they have to move around. And going back to the artists again, artists will certainly be part of that networked environment. So they too can be present in the scene as everyone's working and be able to communicate and also edit that scene live. So the changes that they make, editor VR, on the desktop, wherever, they can be reflected onto the director's scene, onto the actor's scene in real time.
And so on the recording front, we've touched on a lot of these things already. We already have track cameras, real ones. We have track cameras, virtual ones. We have multicam. We do 4 and 8K recording. That lets you get into really high quality. It's not limited by screen space. Some solutions out there have a monitor size resolution challenge. We do subject lighting of actor and scene, real world and VR viewfinders, and then of course the post-processing stack. Looking forward, where are we taking the recording further? I think networked actors is really cool. That lets us actually do live performances, so we're actors interacting with each other, but they're in different environments at the same time. Director could be seeing both of them as projections in their headset, so they're now able to direct 2 actors who are in physically remote locations. That's pretty exciting. As we get into 3D, that lets us go even further. We now have the full depth cameras there, so we got these 3D actor representations, which means the actors potentially can, they'll be looking at monitors around the scene. They can see each other. Virtual cameras can move around with this, really frees those cameras from being able to work with the actors, frees the actors to be able to work in disparate locations, frees director and camera people to all be in different locations. Really all about, how do we take this set of stuff and change the way that we work. We can actually now have disparate, dislocated filmmaking in a different way. We get self-driving AI. We can have autonomous cameras that can do things like subject following, face detection. We can do classic shot composition, knows how to do things. Think about some of the Cinemachine that we saw last night. Coupled with knowledge of the actor, knowledge of who its particular subject is that it's following, knowledge of classic cinema techniques. And then, go from there, we get real drones, coupled with an AI camera control or a human operator to control these drones. And because we have 3D projections, we can have these drones moving around and recording shots and scenes as they exist, either in person or from remote locations. And another technology that's pretty exciting, Google's shown some stuff on this, is actually live headset removal. Yes, at some point we'll have contact lenses or be jacked in, we'll be able to be connected, but until we get there, we'll get lighter and lighter weight headsets. What do we want to do? We want to remove those headsets on the fly. So that way the actors could actually be in VR with each other, and we got eye tracking inside the headsets. Toby's working on some really cool stuff there. And so now, they can interact with each other, and everyone is seeing the actors with, the faces replaced, the eyes connecting. They're able to emotionally connect with each other, even though they're not there, but it feels like they are.
And that starts to get a little bit into motion capture, performance capture, because now we're starting to incorporate some of that real performance with digital characters. And we know that there's already a number of solutions on the hardware and software side to enable the motion capture that we want through Unity. A lot of it's done with inverse kinematics, so you can certainly see a lot of solutions out there right now. But at a baseline, what we're able to do is use a single Vive tracker to approximately peg the location of a live actor in the scene. And now if we include that headset and controller that they might be wearing, we can actually start to rig up a full humanoid character with head and hand tracking. And because we've got hand tracking with the controllers, these actors could actually pick up virtual props and wave them around and manipulate them. Now, if we look into the future again for motion capture, We want to incorporate these solutions much more deeply into Mixcast so that the actors, even in remote locations, can be creating digital characters and animating them on the fly. With virtual cameras, now we're completely free to capture the scene from any perspective, given that the character is actually virtual to begin with. And we can also use trackers for non-humanoid characters if we can do some puppeteering, where we're creating digital puppets on top of these trackers. And again, going back to hand tracking with leap motion, things like that, we can actually capture at this point both body and hand tracking, including the fingers, which I don't think has been possible before. And because we're now able to track the hands with no controllers, we can do more interesting interaction with the scene that allows the actor to have more interaction without needing to be holding anything else.
And so then if we think about post, again, our goal is to try and make this as much of it real time as possible. But the fact is, there's going to be things that are going to want to be done in post. So fine, we output in a quadrant mode. We can give you those layers. We do record the digital content that lets people process it afterwards. There's going to be all sorts of solutions out there already. Our goal is just to make sure that that content's available in the types and the ways that you need it, so you can use the traditional solutions that you're already experienced with and are already using. And so if we think about post going further, though, we get a lot of interesting things. One of these is replay. And so replay is this concept where it allows us to record a full video of the subject, as well as all the tracking information on a frame-accurate basis. So that's then starting to separate the various different components that we're using into their individual pieces. And we can do a lot of things with that in terms of how we manipulate the scene later. So we can now go back in post, and we know how all the pieces line up. So we can re-render that digital content, which means you can use blocky assets early on. You can replace those assets just like you would, except now we're doing some of these things in interaction with live actors or with motion captured performances. We can relight the scene. We can apply post-processing stacks. Or we can even, we can move actors around, and they'll be lit appropriately according to the new placelet they're in, and their performance is still in the same situation. We can even add actors into the scene. We can think of those real actor performances now in almost the same way that we think of a digital asset, because we can now move those digital assets, the actor performances around, relocate them. We can even do things when we get into the depth camera side of stuff, where we've now got this scene and we can actually change the camera location. And so we can move, we're like, oh, it was a great performance. I totally want to get that, but I wish the camera was 5 degrees to the right. No worries, let's just move the camera 5 degrees to the right. Don't need to reshoot it, and change locations, and it really changed the way that you're compositing those shots and giving a director new capabilities that they've never had before. And then, of course, you can also do things like different render pipelines. Because we've recorded all of the pieces and the performances, we can now output this using Octane or other solutions out there. There's a number of those. A lot of stuff in here, really. I think that the goal with this, though, is to make it accessible to everybody. The idea here is that it can be done with a standard Vive system, a camera, a tracker, and Mixcast. And the goal is to make it work for all levels of experience, everything from indie to pro. We do support the higher end recording capabilities and the higher end quality. So a lot of it is just down to what equipment do you have, what do you want to bring to the thing. As we talked about, as we get into networked, we can have multiple cameras, multiple people. You can support a large crew in doing this in terms of being able to support different levels and different calibers of filmmaking shoots and filmmaking styles, and also support those remotely.
So we kind of want to go through a few concrete case studies, not saying that they're possible at the moment, but we want to sort of get into some of the details about what you might experience if you're working on one of these types of cases. So the first one we're going to talk about is using VR in a studio environment. And then we also will talk about a little bit about using a phone for AR capabilities, get into some esports stuff a little bit later, and then talk about casting. So for VR in the studio, we want to talk and imagine as if there were 3 locations, physical locations, that have been networked together here: an acting station, a directing station, and a set design station. At the acting station, we have the green screen, as we previously mentioned, and we have one actor in there that's wearing a single tracker just to be able to approximate their position in the scene. And we have the camera operator who's also using a tracked camera in this case, depth enabled, might as well. They're wearing a VR headset, and they're filming that actor in mixed reality. At the directing station, we have a director, and they're also wearing a VR headset, and they're observing this digital scene, including that actor, like we mentioned before, about having them projected into that scene, and they can even be aware of where the camera operator is and what they're looking at. We want to be able to set up a command center as a director with multiple displays that's able to show us what we're capturing from a variety of perspectives. So this is using the virtual cameras and real cameras in this case with the cameraman that's operating in the acting station. And the director also needs to have voice communication with all of these personnel in both the acting station and the set design station to make sure they can communicate clearly. And in this case, we decided we'd throw in a second camera operator. This camera operator is not actually filming a subject in the same room as them. This camera operator is wearing a VR headset and holding a tracker or a controller that is going to manipulate the position and rotation of a virtual camera on its own. And so this becomes a totally freeing experience because this cameraman could decide to scale the world down. None of the other people in the scene will experience that. But now this cameraman has sort of a Godzilla scale ability to create helicopter shots or crane shots just using a virtual camera to capture that scene. Because the original cameraman was using a depth camera, the virtual camera can sort of be moved around without compromising the quality of the actor too much. On the artist side, as we talked about before, we want them to be able to have a lot of influence on what's going on in the scene as we're trying to capture this. So they're wearing a VR headset too. As we said, they could be using Editor VR to manipulate the set using tracked controllers. And of course, they're going to be taking some set design direction from the director. And those changes are going to be immediately reflected back to both the actor, all the cameramen, and the director.
So we take a second example. Let's take AR on the street. We got 2 locations in this one, mobile station and an acting station. If we think about the mobile station, we've got our director, they're walking down the street, they see a location they think is fantastic. They're like, oh, wow, it would be great if I shot something here. In fact, let me do that. So I've got my phone, I pull my phone out, frame it, I think this looks really good. Okay, so let me say, I want my actors here. Let me make a mark in the 2 locations where my actors are going to be. And then what I do is I actually record the shot. So now I'm going to record the location as if there was an actor there. Because of course I've got my film in my head. I know what I want to be filming. And so I start moving the camera around because of course we're in AR. I can track the locations of the camera and where that's going using SLAM. And so I've now shot my scene. I'm ready to go. So now let's shift back to the actor station because the actors weren't there with me. It's hard to carry those around with you while you're on the go. But later on we say, okay, hey guys, let's get together. And so what we do is we take our screen, green screen, we let people remove the background, and we pop an actor into the scene. So in this case, they actually don't even need a tracker because we know where they're going to be, we know where we're going to direct them. So they're able to come in, they can now act their scene. They can actually watch their scene on a live composite with the camera moves in place as they occur with them in that scene, and they can do as many takes as they want. We can actually have additional actors record scenes as well. We can now add layers of actors into these scenes and enable us to, again, create a new shot in a time-shifted way as we add these additional actors in. And so as those additional actors are added in, they can actually see each other as well in the composited scene, and they can interact with each other and have essentially play off each other to create great acting performances that you really get when you get a couple of people who are acting together. And the other thing we have at that acting station is a camera operator. So popping our camera operator back into the VR headsets. So now what they need to understand is, where's the location in the vector of the camera previously? Because, there is some skill in this part where, they're now going to be utilizing their own technique to orient the new physical camera to match the location previously. So they're recording the actor from the same location as the previously recorded camera was. Now they want to follow those movements close enough so that the actor, again, lighting looks right, the background looks right, these things look correctly. As we add depth cameras, the flexibility increases. So we no longer necessarily have to track the exact path if we're actually adding the 3D representations of these actors created using multiple depth cameras. It actually gives us the ability to eliminate the camera operator. And at this point in time, whatever the camera movement is pointed at that character. It's going to be correct. The actor projection will be correct, and the interaction with that location previously filmed will be correct. So this really allows us to now create time-shifted films recorded out on the fly using essentially equipment that you just happen to have with you.
So we wanted to do one smaller case study here about casting extras, because I'm sure that's been a bit of a headache for a lot of cinematographers in the past. With our new technology, this would become a lot easier to collaborate on and distribute over multiple locations. In fact, the extras' auditions could actually be their performances if they're recording in front of a green screen. They can send in that data with the tracking as well as the video and allow them to be inserted into any sort of production using that replay functionality. Actors that are in the studio, once we've got the extras footage submitted, could actually see that performance playing out, either with a VR headset on or in a composited output once they've been inserted into the scene. And they can respond to that acting. The director, of course, can actually be placing these extras and their performances all over the scene. They're not limited to one specific location anymore. So you could decide that you need a few more up on top of the building or down on the street and just manipulate those on the fly.
And so the final case study we want to talk about is esports or V-sports. And in this example, we're going to talk about a single location. This is a shared arena. Everybody in that arena, all of the athletes are present in the same physical space, but they're each wearing their own wireless VR system. This technology exists today. I was in Las Vegas, I think 2 weeks ago, using the zero latency system where there's 8 of us in a room. We're all walking around, connected, networked, wired up with microphones. It's a pretty cool experience, right? I mean, and this is where we see this stuff going, and we can imagine again how this works with an on-set situation and how this works in virtual reality esports. Because really, when you get to virtual reality esports, it's going to take our current esports athletes and truly turn them into athletes. They're going to be able to run around, they're going to be physical, and when we add mixed reality to this, we're now able to put those people, they become stars, they become just like other athletes do, because the audience, the consumers of this content, will be able to watch them at home. They'll be able to watch them on screens in arenas as these things are created. And so we can place multiple static depth cameras around that enable us to capture 3D video representations of these actors. We can now be capturing multiple virtual actors simultaneously. And the camera operators, wearing VR headsets, holding track cameras, can now follow these athletes around while filming. And so we're now able to isolate multiple subjects. They're able to have an incredible experience going on, and we're able to project and record this and have an audience live or after the fact watch this experience. And so on top of that, we can now add drones. We can have drones that are autonomously AI controlled, and they can follow this around, and they can actually react to gameplay. They can follow specific players. They can be holding real cameras. They can actually be holding virtual cameras. So we can essentially get a whole different set of shots aligned to be able to create the best virtual reality esports presentation possible. And then we add the director, and the director gets a pretty exciting job at this point in time too, because they now have a huge number of shots available for them to be able to pick from in order to create the best presentation possible of the V-Sports experience. And so they're able to switch between the active shots from a static camera, from a camera-operated camera, from a drone camera, or from a virtual camera. And then later on, we actually see how the director could actually be assisted in this. Let's say a camera thinks it's doing something interesting. It could flash that screen. It could highlight things. We can move to a place where we actually have an automated process using heuristics, where depending on where the viewer is located, for example, they could actually get a different presentation of the experience, because they could have camera feeds that were following athletes from their countries or their favorite players or other things like this to be able to create that custom experience for them as a viewer, even though everyone's actually watching the same live event. So a lot of stuff in there. Anyway, that's kind of what we see going on in virtual cinematography. We think a lot of this is going to be disruptive and really be able to change a lot of ways that people film. And we thought we'd open it up to questions. And I guess we've asked people to come up to the microphone if you have any as their recording thing.
Thanks. Great presentation, by the way.
Thanks. Thank you.
So I've dabbled in this a bit myself over the years, and for a while, I was using just like a RealSense camera and segmenting by depth only without the need for a green screen.
Yeah.
And of course, the resolution on the depth cam, horrible. It's gotten better over the years. I'm just wondering if you've given thought and have any hope that the green screen may someday go away and we won't really need all that.
Yeah, I don't think it's going to take very long at all. We're already seeing this new wave of depth cameras come out that are sort of coming along with the VR and immersive computing ecosystem. The Z camera is one. The new RealSense cameras that are being shown now are another, both using stereo cameras to try to determine depth. And we find that the resolution's a lot higher. Some people have still found that it can't quite get that nice clean outline on a player. But we're continuing to push that forward and trying to consider more software solutions to deal with some of those hardware limitations. But of course, the hardware will continue to evolve as well.
So I watched the Otoy presentation this morning, and they have this nice AI denoiser that can sharpen up edges like that.
Yeah.
I was wondering if you guys could talk about that and sharpen up our depth images so that we can really get a nice clean, you know.
Absolutely. I mean, eventually we'd like to get that to be a real-time process because we're talking about replay as a function in the future where we no longer have to capture everything in real time. We can actually go frame by frame and render through. We could process backgrounds and try to remove them through longer AI processes, but we have seen some research that's showing that potentially AI can determine what is the background and what is the subject without a green screen required. So.
Yeah, and I think there's some AI solutions now that have had some papers published on them that do that. Again, they're not really accessible on consumer grade yet, but I think we're going to see this, very rapidly move towards the capabilities of having that background removal or subject isolation occur without having to use a green screen.
Right. I'd like to see that applied also to stereo panoramic stitching, get rid of the stitch lines. And that was my next question: was have you done anything with, stereo panography?
Yeah, I mean, photogrammetry, I think, is a great place to start with that and get something that can be captured with mixed reality. It's a nice way to get photorealism in your scene as well as your actors. But we haven't looked too much further. We're really focused on the 2D screen right now, and eventually, yes, we'd like to get into stereoscopic 3D output. But right now, we just want to make sure that we can broadcast to the widest audience with the 2D screens.
Right. Thank you.
Thank you.
I'm just curious what the setup is to make sure that you're getting frame lock between the Vive, all the lighthouses and everything, as well as your when you're actually shooting something on whatever camera, Red or something like that.
Yeah, the pipeline has a few different components to it. The Vive system is very fast and very accurate. So you usually get its tracking data before you actually get the camera feed to come in for that same sort of time. So we have solutions available that work on any application to buffer the game feed or the application feed so that it can wait the required amount of time to be synchronized with the camera feed. So that currently is a manual process where you sort of tweak your offset, your buffer time, but eventually we can also see that becoming an automated process.
Cool, thanks.
So we did a basketball project for Madison Square Garden and the Knicks, and we made a commercial in mixed reality showing off the basketball game. And so I just want to give some warning on the leap motion kind of predictions you guys are putting out there. So we did a version where instead of using the controllers, you can actually grab the basketballs, throw them, spin the ball in your hand and stuff using leap motion because we're doing some stuff for them. But it's kind of impossible actually to get the leap motion to work with the HTC system because the infrareds just kind of cancel each other out.
Yeah, is this using the existing desktop USB device?
Yeah, but we've definitely looked at some of the prototypes from later, but I just want to give kind of a little bit of a warning.
Sure.
And so I would just say, as a filmmaker, so I used to work for Rooster Teeth, and now I have my own VR company, that it would be a lot easier just in the first iteration to just use a controller, knowing that that control and those inputs are going to work instead of having a bunch of actors, a bunch of people on set, and you're going, this isn't showing where my hands are.
Of course, yeah. We want to definitely get to a point where that can be a reliable interaction because if you blow your shot because of that, that's not great. We are experimenting with the leap motion and can continue to see how that software will improve in quality. I think the new devices are definitely going to be a big improvement given their field of view and accuracy, but we're certainly just trying to open up the options available and letting you guys decide whether you want to use them.
And that was my second question. So with the pipeline, with the leap motion and the drones and all this, a lot of this is just theory. A lot of it's not actually implementable now, and having drones with the 15 by 15 room scale doesn't really kind of make sense. And
we've actually seen videos of drones with trackers on them that are being controlled by a computer. We partnered with Intel a few weeks ago, and they are also exploring the drone. They haven't quite gotten it off the ground yet, but this isn't in the far future. This is being tested and developed on.
Sure. I guess my question is, from all the stuff you guys listed and what you guys actually have available in the Mixcast, how much of that is implemented, how much of that is theory, kind of this would be cool, and how much of it is multiplayer, all that stuff actually built into the Mixcast versus it just kind of being like an easier version than OBS?
Well, certainly it is currently a much easier version of OBS. It does all of the live composites, it does that sort of thing, and along with the other features. Yeah, some of the networking pieces, those are on the roadmap, and we haven't done that yet.
Okay, thank you.
Thank you.
I was going to ask, so imagine your presentation was disruptive cinematography on a virtual budget. Tell us where your stack is now, and you referenced some things that were coming in the future, starting with the basics. I think your studio green screen as an example. Where is your software and where is your product stack now, and what is the timeline for some of the other stuff you were talking about?
Yeah, so our Mixcast system has a few components to it. We have Mixcast Studio, which is sort of the command center where you can, you'll be run through configuration. Camera alignment, one of the big processes there, gets handled in that, as well as deciding on your background removal and configuring parameters for a variety of aspects. That, once you've saved those configuration files, can then be carried over into any application with the Mixcast SDK. So any Unity application can drop that in. There's 2 prefabs, and when you hit play, you should be able to see mixed reality start being created right there. So we've handled the camera alignment. Our background removal, we've got green screen as well as a no green screen option for fixed cameras. Lower quality, of course, right now. Third option that will be coming soon is the depth cameras, for sure. We see that being a great path forward in a number of ways. And we also continue to push that SDK further because we want deeper integrations with these applications so that it's up to these Unity developers to decide what they want to capture and how to make it look great.
I don't mean to steal back, but so is Unity your primary axis of integration for this type of market?
It certainly made things a lot easier. There have been a number of areas where we've had to go deeper, and currently we're working on bringing our Unreal plugin out as well. Because we do want to try to open this up to as broad an audience as possible, or as broad a base of developers as possible.
4K and 8K, that's pretty exciting. I've worked with those before. They are enormous.
They are.
I'm wondering, I understand that for actual delivery, but when you're doing it live, what's the highest resolution that you support? What does it look like? Are you using proxies?
We've recorded in 4K, both the digital and the physical camera being 4K resolution, and saving that file out. So it's beyond theory, it's possible. It's just going to depend on what your hardware looks like, your hard drive, your graphics card, things like that.
But live compositing? I
This
understand
is live, yeah.
Wow,
Yeah.
okay.
Yeah. And on the 8K side, we don't have an 8K camera because they cost too much.
We can do 8K digitally already, real time.
digitally real time.
Yeah. And we support 30, 60, or 90 FPS. It also depends on what the digital content is, right? Because performance will vary depending on how detailed your environments get.
Yeah. Certainly, I know, if you get a really complex scene and you're starting to run multiple cameras and multiple things, that's another place where, if we think about tech stack in future, networking comes into play, because now we can start having each individual camera on its own dedicated machine able to be present in the same virtual scene. And so, it's a very high priority. I think, you asked what's the timeline look like. We're talking in the order of, probably first quarter next year is when the networking comes in, because we recognize just how many things that unlocks, both in terms of the, availability of powerful hardware. Right now you got to do everything on one machine.
Well, what's possible today, if you already have coded up a multiplayer game, is that you can use that multiplayer functionality. If you have a spectator mode, these cameras can all be done through the spectation mode, which is where we see the esports going, because of course they're already multiplayer. Now they can just set up additional spectators to capture that performance. But we also want to try to provide a more sort of standalone solution that allows filmmakers and creators to drop in assets and have that networking happen sort of automatically under the hood, because we know how hard that can be.
Keep up the good work.
Thanks.
Thank you. If you guys are interested in learning some more, you can go to that URL, contact us. Happy to get you early versions and work with you guys if you want to check the stuff out. So thank you very much.